So this is going to be problem number 11, exercise 2, chapter 1 solution of equations from the book Higher Engineering Mathematics by Dr. B.S. Grewal. I want all of you to watch this video right till the end because this has appeared very, very frequently in a lot of university examinations. And by the way, I invested around 1.5 to 2 hours. Okay, obviously in my copy. I first make the solutions in my copy and then I do it using a pen tab on PowerPoint. But I was not able to crack it, to be very, very honest with you. I made a phone call then to a very good friend and colleague, Chandrakar sir. And I asked him, sir, iska solution bana ke dijiye. Please make a solution to this problem. He solved it and he sent a solution to me. Okay, and it is that solution that I'll be sharing with all of you in my own style. And thanks to Chandrakar sir. Here we go with the solution. I want all of you to read the problem description with me so that all of you will get confused. Let's read it. Find the equation of the square differences of the roots of the cubic. X cube plus 6x square plus 7x plus 2 is equal to 0. And by the way, this will take me around 10 to 15 minutes. So be patient. Okay. Thoda dharya bana ke rakhe. And this video has already been made in Hindi. If you want to watch all the videos, you surely can go to my channel, BTech Plus. You'll see all of these videos, mathematics videos, and in Hindi. Okay, watch them from the playlist. How do we approach this, sir? So this is your given equation. Let's say it has got roots alpha, beta, and gamma. Very well, sir. The equation that you guys need to work out, that is your required equation, is going to have roots in the form of square differences. That means alpha minus beta and its square, beta minus gamma and its square, and in the same way gamma minus alpha and its square. It is for these three roots you need to frame an equation. Now how are you going to approach this? If you go by the conventional approach, what you will do is you'll say that's a y is equal to alpha minus beta and its square. Okay, sir, we can also write it as alpha plus beta and square minus 4 times of alpha beta. Yes, you can do that. No problem. Sir, we can also do alpha plus beta plus gamma minus gamma. It's square minus 4 alpha beta. Let's multiply by gamma and divide by gamma. Sir, we can do this also. Sir, here we'll end up with sum of the roots minus gamma and its square minus 4 times of product of the roots divided by gamma, isn't it, sir? Sir, we can clearly see that y has been expressed in terms of gamma and we can later on replace gamma with x and our job will be done. If you follow this approach, what will happen is you are going to end up having terms like y gamma cube, gamma square, gamma, and no gamma terms also are going to be there. Okay, non-gamma terms are also going to be there. That is the problem. What you need to do in such cases, I mean, this is something that we've been doing in the previous sessions also. We actually had to express gamma or x in terms of y. So there was a problem with this approach. How to tackle such questions? You need to eliminate this x square term. You need to make another general equation which does not have this x square term in it. Try to eliminate this the moment you see a problem based on square differences. Here we go. How to eliminate it, sir? Let us add all of these roots. Alpha plus beta plus gamma. Obviously, it is going to be minus of plus 6 divided by 1. Let me do that. If you want the sum of the roots, by the way, to be equal to 0, okay, what you need to do is, let me first of all write this again. Alpha plus beta plus gamma is minus 6. I'll add plus 6 to both the sides. Please watch. Okay, sir. What will happen? The RHS will become automatically 0 and this 6 can be split up into alpha plus 2, beta plus 2 and gamma plus 2. Let me immediately do that. Okay. So in order to eliminate this x square term, you should have roots in the form of alpha plus 2, beta plus 2 and gamma plus 2. Fair enough? Okay. Now, we also know that the following approach is true. That the moment you divide f of x by x plus 2, you are going to get that equation which has a missing x square term. Right? Okay, sir. So x plus 2 is equal to 0, x is equal to minus 2. Why have I done this? The reason being very simple. We don't follow the long division approach. We follow the synthetic division approach. And you have to divide it by -2. You can also do one thing. You can apply this simple formula. H is equal to -1 over n, A1 by A0. And by the way, this is A0, this is 6 is A1, this 7 is A2, and that's A3. So if you apply this formula, -1 over n, n is the degree happens to be 3, A1 is 6, and divided by A0 is 1. If you plug in all of these values, what you get is again 2. So -2 by the way. So this is one way of approaching it. Okay. Now let's go ahead and let's do the division. It is the remainders of that division process that we are interested in. Okay. Remainders of the division process. Obviously, f of x is not exactly divisible by x plus 2. It is going to leave some remainders, and it is those remainders that we are interested in. And that will help us frame another equation. Let's do that. Okay. So 1, 6, 7 and 2. 1, 6, 7 and 2. What are you going to divide it by? Sir, we are going to divide it by x is equal to -2 or -2 to be very simple. Done, sir. Copy paste. -2 into 1, -2. 6 minus 2, 4. -2 into 4, -8. -1. -2 into -1. 4. This is your first remainder, by the way. Okay. So there are going to be 3 stages. Why 3, sir? It's a cubic equation. Had this been an equation of degree 4, there would have been 4 stages. For degree 5, 5 stages, and so on. Copy paste. 2 -2 into 1, -2. This is 2. -2 into 2, -4, -5. That's your another remainder. Copy paste. -2 into 1, -2. -2 plus 2 becomes 0. So let's start now. This is going to be, you can see the second term is 0, and that is exactly what we wanted. We wanted the second term to be 0. And for the second term to be 0, your roots should be in the form of alpha plus 2, beta plus 2, gamma plus 2. Please try to understand this. So this is going to be, sir, 1x square plus 0. No, not 1x square. Rather, it's going to be 1x cube plus 0 times of x square minus 5x plus 4 is equal to 0. Let me write this equation. Okay. I'll number it as equation number 1. Done, sir. So far, so good. What we've done is we have revised basically our general equation in such a way that this square term is missing. This is the equation. Okay, sir. Now what? Let me update this. Now our general equation is, instead of writing this as our general equation, let me write this. Here we go. X cube minus 5x plus 4. Here it is updated. X cube minus 5x plus 4. And instead of writing alpha, beta, gamma, let me write alpha plus 2, beta plus 2, gamma plus 2. I hope you're getting the point. Okay, sir. So far, so good. No problem. But sir, this is going to get confusing. I mean, until now, we've seen alpha, beta, and gamma only in our general equation. And here, there used to be different combinations between the roots. Now, what we see is alpha plus 2, beta plus 2, gamma plus 2. I think we can make it much more simpler. Let's say alpha plus 2 is A, that's B, and that's C. Now, what is going to be A minus B? Sir, A minus B is basically alpha plus 2. Here it is. Minus beta plus 2, matlab beta minus 2. Okay. Minus of beta plus 2 is, when you open the bracket, it is beta minus 2. So 2 and 2 will cancel. It is going to be alpha minus 2. Alpha minus beta, by the way. So if you watch, A minus B is equal to alpha minus beta. Can we say so? Yes, sir. In that case, A minus B whole square will be equal to alpha minus beta whole square. So alpha minus beta whole square can be written as A minus B whole square. In the same fashion, B minus C whole square, C minus A whole square. So far, so good. Now, let's start some serious business. What is A minus B whole square equal to? Expand it. This is something that we already know, sir. Can we squeeze in plus 2AB and minus 2AB? Will it make any difference? No, sir. Let's do that. No difference whatsoever. Okay. Sir, this actually constitutes A plus B whole square, and that's minus 4AB. Fair enough. What can we do? Sir, we can say that this is A plus B plus C minus C. And here let us multiply with C and divide by C. Okay. Let's do that. Sir, we can clearly observe that this is resulting in sum of the roots, and this actually results in product of the roots. Let me write it in that fashion. If you watch, we already know that the second term is missing. If the second term is missing, then the sum of roots has to be 0. And that was the premise to get this equation. And the product of the roots is going to be equal to negative sign over here, minus of plus 4 divided by 1. So it is going to be equal to minus 4. Okay, so plug in 0 over here and minus 4 over here. And now what we can do is minus c and its square. This is going to be c square minus minus is plus 16 over c. Right? Let us replace c with xy. This c can be replaced with x. In the same fashion, this a minus b can be replaced with y. This is something that we've been doing in the previous problems also. Please refer to them. If you are directly seeing this video, please refer to those videos first of all. Only then you will be able to work out what is happening over here. So yes, y is equal to x square plus 16 over x. If you take the LCM, x will be transferred to the left. Okay, and xy will be equal to x cube plus 16. So let me write this in a much more meaningful manner. So this is our second equation. Sir, there was one more equation that you marked. X square minus 5x plus 4 is equal to 0. This is our equation number 1. And this is our equation number 2. Here it is. 1 minus 2. Let's do that. And let's eliminate the x cube term. Done. Let me write both of them. Here we go. X cube minus 5x plus 4. X cube minus xy plus 16. Here it is. Okay. All right, so. Sir, the x cube terms are going to cancel each other out. Let me do that. So this becomes minus 5x plus 4 plus xy minus 16. It is right there. Now you can see this x can be taken as common. Y minus 5 and this plus 4 minus 16 will result in minus 12, which can be taken to the RHS. Okay, it will become positive 12. It's very simple now. You need x in terms of y. So x is essentially equal to 12 upon y minus 5. This is our transformation. We finally reached the transformation, which we are now going to plug in over here in place of x. The moment you do that, you will have an entire equation in terms of y, and that is going to be your required equation. X cube minus 5x plus 4. So x cube minus 5x plus 4. Instead of x, what you can replace it with is 12 upon y minus 5, which I am doing over here. Let's finish it off. Okay. If you watch, if you see that there is a cube over here. So y minus 5 cube, 12 cube is going to be 1728. So y minus 5 cube, this is y minus 5. This is 1. You can say that. Okay. So better to take the LCM as y minus 5 whole cube. By the way, this is 1728 and 12 cube is 1728. 12 into 5 is 60, and here we are going to have y minus 5 square, y minus 5 cube. Now all you need to do is to expand. Let me write this. Expand y minus 5 whole square. So this is going to be y square plus 25 minus 10y. Similarly, a minus b whole cube. A cube minus b cube minus 3a square b plus 3ab square. Implement these formulas. This is what you get. Open the bracket. If you watch, this is the cube term. This is the only cube term. Plus 4y cube. Minus 60y square minus 60y square will be minus 120y square. You can see that you have to frame an equation from higher powers to lower powers. This is what the final result is going to be. You can even refine it. You can see all the terms are divisible or are multiples of 4. So you can divide the entire equation by 4. The moment you do that, this is going to be your final equation. Y cube minus 30y square plus 225y minus 68 is equal to 0. So we are almost 14 minutes and 33 seconds into the video, and I'm sure this has added value to your knowledge of higher engineering mathematics and, to be very specific, solution of equations. If you find this content helpful, do like and share the video with all your friends and classmates, and do subscribe to the channel and also press the bell icon so that you stay notified, you stay updated whenever I upload any new video. This is Manas Patnaik signing off. Take care. Have a nice day. Thank you.